Hey guys, this is day 2 of acids and bases. We're going to talk about how to name acids and name bases. So it's going to be page 3 and part of 4 in your packet, and then you are going to have a homework assignment. I've been grading your homework assignments on accuracy because you have your note packet right there. However, I think I am going to drop your lowest homework grade. Just so, you know, if you have a bad one or you didn't understand something, that should help your grade a bit. Okay, so I think that's all we need to talk about first. Okay, so open up to page 3. You run in place. Count to 50 while you're running in place. My son's doing gym class right now. Okay, so you are going to need a reference table handy if you have one. You should have one, or you can just Google it. Okay, so this is page 3. Okay, here we go. All right, so why don't you do 20 more jumping jacks? Okay, so binary acids contain 2 elements, prefixed by. They always contain hydrogen and a non-metal. So to name whatever you have, the hydrogen gets renamed to hydro. And then the non-metal ending is dropped. So like the chlorine, you drop the INE ending, stuff like that. Iodine, you would drop the INE ending, and you add IC. And then you add the word acid. So let's go through the rules of the HF. So H gets changed to hydro. Fluorine gets changed to fluoric, and then you add the word acid. So hydrofluoric acid. Ternary acids contain hydrogen plus a polyatomic ion. So in your packet, there's the table E with the selected polyatomic ions. So to name those kind of acids, so something that has more than 2 elements, basically, you are only going to look at the ending of a polyatomic ion to decide how to name it. If the ending of the polyatomic ion ends in ATE, you would cross out ATE and you would add an IC. So you're not going to have this hydro like you did before. You're just going to take the polyatomic name, drop the ATE, add IC, and then you add the word acid. If you have an ITE ending, you add an OUS instead. So go ahead and look up CO3. So that's the polyatomic. So the polyatomic in this one is named carbonate. So you take carbonate, and then instead of writing ATE, you write IC, and then add the word acid. So carbonic acid. So there's no hydro. NO2 is nitrite. So instead of writing nitrite, drop the ITE and add an OUS. So this would be nitrous acid. Okay, so now you're just going to practice those 10 example problems below. One thing to be careful about is that sulfur and phosphorus don't actually follow those rules. So like number 8, 10, and 6, you might just want to wait till we go over those. So 8, 10, and 6. Okay, so push pause and try answering those questions. And then when you come back, we'll go over it. Okay, so HCl, binary because there's 2. So hydrochloric acid. I'm going to do all the binaries first because they follow the same pattern. So hydro, bromic acid. Hydroiodic acid. So iodine changes to iodic. And then the last one, sulfur, I was saying is kind of a weird one. So hydro, so instead of saying sulfic, it changes, it just keeps the full name sulfur and adds an IC. Hydrosulfuric acid. Okay, so the rest of these are going to follow the rule where ATE changes to IC and ITE changes to OUS. Okay, so let's look up NO3. Oh, it's nitrate. So nitric acid. ClO4 right here, perchlorate. So instead of perchlorate, drop the ATE and you're going to add IC, perchloric acid. H2SO4, so this is another sulfur one that's a kind of a weird one. Sulfate. So instead of calling it sulfic acid, it's going to be sulfuric acid. Okay, and then C2H3O2 is acetate. So drop the ATE, add an IC, acetic acid. This is vinegar. Okay, and then PO4 is a weird one. It's phosphate. Instead of phosphic acid, you call it phosphoric acid. And then H2CO3, CO3 is carbonate, so it's carbonic acid. So it looks like I didn't give you any that go to OUS. But for example, this one, chlorite, could be chlorous acid or hypochlorous acid or sulfurous acid. Okay, flip to the next page, please. Oh, before we do that, I forgot, we're going to talk about what's in your reference table. So if you look at reference table K, there's a list of acids there. So these are the most common acids that you'll use. So HCl, hydrochloric, nitrous, nitric, sulfurous, sulfuric, phosphoric. So these, the weird ones are there, so you don't have to memorize that. Carbonic and ethanoic acid, or acetic. I always call it acetic acid. Okay, so naming bases. These are easy. So naming bases. Bases are always going to contain a metal combined with hydroxide, which is OH. So to name the base, you name the metal. Magnesium. And then you name OH, which is hydroxide from table E. Magnesium hydroxide. Okay, so take a minute and do questions 1 through 7, because number 8 is a weird one. And then come on back and we'll talk about the answers. Okay, so KOH, move this all the way. Name the metal, potassium. Name OH, hydroxide. Okay, NaOH, sodium hydroxide. AgOH, silver hydroxide. I did not give you any that you need a Roman numeral for. But remember, if you have transition metals, except for silver and zinc, you'll need a Roman numeral. Calcium hydroxide, zinc hydroxide, lithium hydroxide, aluminum hydroxide, and then the last one, NH3, is in reference table L. This is called ammonia. Okay. So just like with the acids, the bases also have a table that gives you some common bases. So sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonia. Okay, so that's it for today. Then we'll pick up tomorrow, and you're gonna need some colored pencils tomorrow, or markers, I guess, with crayons, whatever. Okay, so that's it for today. Copy the notes, do the homework. Bye-bye.